Good morning. I'm starting new topic, that is logarithmic differentiation. For this you should know properties of log, which are very important. Why log used in maths? Basic properties of logarithm is first property. These are properties. What are the properties? Log m into n. It is log m plus log n. Multiplied, converted into addition. Second property is log m by n. It is log m minus log n. And third property is log m to the power n is n log m. Power comes forward. Power comes forward before log. And fourth property is if log base and main base both are same, result would be 1. These are very important properties of log. Why we use log in maths? It makes typical calculation into simplest form. The log is very useful in maths. It is useful in physics, chemistry also. Whenever we get typical form, it reduces typical form into simplest form. Like here, we are getting first question of 5.5, cos x, cos 2x, cos 3x. We can use product rule also, but using log makes it easy. There are three functions, u, v, w. We have to use product rule for three functions. But if we use log, this will be very easy. Taking log both the sides. Taking log on both the sides. What will happen? Log y equal to log cos x, cos 2x, cos 3x. Which property will be used? Log m into n into p. Multiply, it becomes addition. Log cos x plus log cos 2x plus log cos 3x. Which property is used? Log m into n. It is log m plus log n. Now we can differentiate easily. So differentiating with respect to x, this is very important. First question you are doing logarithmic differentiation, pay proper attention. If you understand two questions properly, you can solve whole exercise. What is the differentiation? Because of we all know d by dx log x is 1 by x. D by dx log x is 1 by x. Same way, d by dx log y. So this is d by dx log y, d by dx log cos x, d by dx log cos 2x, and d by dx log cos 3x. So because of log, it is 1 upon y, and differentiation of y is dy by dx. It is not log x. If it is log x, we can write only 1 by x. But y is function of x. You have to differentiate y also. So because of log, 1 upon y. पहले log के कारण 1 by y, फिर y के कारण dy by dx. Same way here, because of log, 1 upon cos x, then differentiation of cos x is minus sin x. Directly I am writing. Because there are two functions. We can say this is chain rule. Simplest form of chain rule. I am not using u, v, w. Because of log, 1 upon whatever is given, and because of cos x, minus sin x. And here second term, log cos 2x, because of log, 1 upon cos 2x. And because of cos 2x, minus 2 sin 2x. Already I have explained. Because of log, it is 1 upon cos 3x, and because of cos 3x, minus 3 sin 3x. So this is what? Minus 10x, minus 2 tan 2x, minus 3 tan 3x. After getting simplest form, bring this y this side, because you have to find dy by dx. So this is 1 upon y dy by dx. Now what we can do is dy by dx will be y, and also minus common from right side, so minus y. I brought y this side, it will be multiplied. So 10x plus 2 tan 2x plus 3 tan 3x. Now at last dy by dx should be in terms of x. We know that what is y? Y is cos x, cos 2x, cos 3x. So we'll substitute value of y. So final answer is dy by dx is minus value of y is cos x, cos 2x, cos 3x from our initial step. And this will remain same. Tan x plus 2 tan 2x plus 3 tan 3x. So this is the process. Everywhere whatever function is given you assume as y. Take log, differential log y will be always 1 upon y dy by dx. After simplification of right side, bring this y this side and substitute value of y. This is initial step in each and every question. Like question number 2, we are getting y equal to whole root x minus 1, x minus 2 upon x minus 3, x minus 4, x minus 5. This is also typical form. If we use log, this will become very simplest form. Taking log both the sides. Taking log on both the sides. So this is what? Log y equal to log, we can write this bracket power 1 by 2. X minus 1, x minus 2, x minus 3, x minus 4, x minus 5. Because of under root I have written whole power 1 by 2. And we know that this is the property log m power n will be n log m. So this 1 by 2 will come here. So log y equal to 1 by 2 log, and we can use here property m by n. What is m by n? Log m as log n. So we can write here first of all x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. Now I am using property log m by n. So this is what? Log m minus log n. X minus 3, x minus 4, x minus 5. Which property is used? Log m by n is log m minus log n. Now what we can do is, here we can apply product property. Product will become sum. Here also product property will become sum. So 1 upon 2 we can write log x minus 1 plus log x minus 2, because log m into n is log m plus log n, minus, here also we can use product property. This will become an addition, log x minus 3 plus log x minus 4 plus log x minus 5. When we'll open this bracket, this all will become negative. Now we can differentiate. We have got simplest form, differentiating with respect to x. So log y differentiation is 1 upon y dy by dx. 1 upon 2 constant. Because of log, 1 upon x minus 1, then differentiation of x minus 1. You have to show. Because of log x is 1 upon x. Log whatever is given 1 upon x. You have to write the same thing because it is function of x. Now log x minus 2, 1 upon x minus 2, then d by dx, x minus 2. And here I am opening bracket, log x minus 3, 1 upon x minus 3, then differentiation of x minus 3. Log x minus 4, because plus minus it will become minus. 1 upon x minus 4, then d by dx of x minus 4. And last term is minus sign, plus minus minus, 1 upon x minus 5 and differentiation of x minus 5. So after this we have got the simplest form. We can bring this y here. So dy by dx is y upon 2, and this is 1 upon x minus 1. Differentiation of x is 1 and differentiation of 1 is 0. So we'll get only 1. 1 upon x minus 2. If we bring d by dx inside this bracket, d by dx x is 1 and d by dx constant is 0. So we'll get 1. Here also 1 upon x minus 3 into 1. 1 upon x minus 4 into 1. 1 upon x minus 5 into 1. So now here we can substitute value of y. What is y? From 1, y is root over x minus 1, x minus 2, x minus upon x minus 3, x minus 4, x minus 5. So 1 upon 2, in place of y I am writing x minus 1, x minus 2 upon x minus 3, x minus 4, x minus 5. And this bracket 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. This is the way to do differentiation of logarithmic functions. If we take log, this will become easy for us because this function initial stage is not in simplest form. But if we take log, we get simplest form. Like there are 5 brackets, we are getting 5 terms independently, and we are differentiating after using logarithm property.